this is Mr. Manley. In this video, we're going to look at a word problem that produces a system of inequalities that will give us a range of solutions that answer the question. Reading this problem, I've got a person that's making a up to $500 donation to charity. And the $500 is being divided between two charities, the City Youth Fund and the Educational Growth Fund. And then here I have my variables identified. Let X denote the amount of money to the City Fund, and Y denotes the amount of money that is donated to the Educational Growth Fund. So just taking that piece of it there, if I'm donating up to $500 and I'm splitting it between the City Fund and the Education Fund, and it's up to $500, hopefully you can see that we've got an inequality here where X plus Y is less than or equal to 500. So I'm donating up to $500. I could donate less. And the $500 is being divided between two charities, X and Y, where we've identified X as the City Fund and Y as the Education Fund. There's another stipulation here, or another constraint, where Joe would like the amount of money to the Education Fund to be at least twice the amount donated to the City Fund. All right, so we've got this, he wants some relationship here between X and Y, where the Education Fund, and I'm getting all right, so that's the City Fund, and that's the Education Fund. The Education Fund is Y. All right, so he would like the amount donated to the Education Fund to be twice the amount, at least twice the amount to the City Fund. So if I were to multiply, if it were exactly twice the amount, and I multiplied the Education Fund by 2, this would make sense, right? So whatever the Education Fund is, multiply it by 2, and that would be equal to the City Fund. And that would, so in this scenario, the City Fund, there'd be twice as much in the City Fund, because if the Education Fund was 50, then 2 times 50, City Fund would be 100. Twice as much. Now this says at least twice as much. So what do you think that means? Converting the wording at least twice as much to an inequality, we're going to say that it is greater than or equal to 2y. So that way, if it were 50, it could be 100, but it could also be 101. So that would be more than twice as much, which would be allowed with this inequality. So that may be the tricky part for some students, to come up with an inequality from that statement. If you have trouble with it, use numbers like I did there. I just said, all right, well, what if it were 50? And then work off of that. What if I had 50 in the Education Fund? Well, that would mean I'd have 100 in the City Fund, and that'd be twice as much. 101 would be more than twice as much. So you can usually work things out numerically. Now I think I've got all my constraints represented with the inequalities, and I want to shade the region corresponding to all the values of x, y that satisfy the requirements. So we're going to shade that region, and then we're going to look. Check it out. Does it actually make sense? All right. So I got this is pretty easy, right? If I go, if x is 0, that means that y is 500. So that'll be up here. And if y is 0, x is 500. And that'll be down here. And then we need to connect those to get the edge of that inequality. That doesn't look as accurate as I would like. I don't know if I'm going to be able to use this. All right, I'll be able to use it. That looks good. All right. And less than or equal to, right? Less than or equal to, so we leave the line solid. And less than, that's going to be down here. Something that's not, that I haven't written out, but is implied, and that you would infer, is that we're going to have a solid line here, because we're not going to have a negative donation, right? So it's either 0 or more. Might be 0, I guess, but has to be 0 or more. So that's going to put us in the first quadrant. And then I've got this guy here. Let's not be intimidated by that. Let's put it into a form that looks, let's do something with it that looks more familiar. So I'm going to take this, first of all, let's look at it as an equality, understanding we're looking for the edge of this inequality. So we're going to do it as an equality to get the edge. And I just rearrange this. What if I just go 1/2 x is equal to y? And then reflect it just to put it in a more standard convention. And what do I have there? I have y equals mx plus b. B is 0. That's the y-intercept. So I got a y-intercept at 0. And then a slope of 1/2. So 1/2. So if I go up 40 and over 80, that's 40/80, which is 1/2. So that was up 1 and over 2 with the squares. You'd have to make sure that each square is to the same scale. If that was a different scale, I would have to be careful about that. But they're the same. 40 up, 40 over is 1 square. Okay, connect those dots. And what do I have? I have y is less than. Do you see that? Y is less than. So y is less than means down. So I'm going to say everything down below this edge. And where do they overlap? They overlap here. And then we had that idea that I said earlier, that it has to be greater than or equal to 0, right? Can't donate less than $0. So there it is there.